Welcome to the third preparatory stage science course. I am Rania Hasabo and I am going to be your teacher here during this course. The goal of this work is not only for the exam, but also for understanding and linking information to the life around you. Wish you all the best of luck. Now let's start. Every day you deal with a lot of numbers, like 80 kilogram, 20 minutes, 10 meters. We have known 80 kilogram is mass, 20 minutes is time, 10 meters is length. The greatest part of physics is physical phenomena. Anything that the human can measure is considered as physical quantity. To identify the physical quantity, you must know its magnitude and measuring unit. Physical quantity is any quantity that can be determined and has a measuring unit in our life. Each physical quantity is measured in a special measuring unit, like time, which is or hour, distance, meter or kilometer, speed or velocity, meter per second or kilometer per hour, acceleration, meter per second square, temperature, Celsius or Fahrenheit, energy, joule, weight, Newton, and also force is measured by the same unit, Newton, mass, which is kilogram, density is gram per cubic centimeter. We have two types of physical quantities: scalar physical quantities, vector physical quantities. What's the difference between them? Scalar physical quantity is a physical quantity that has magnitude only and has no direction, while vector has magnitude and direction. For example, scalar: mass, energy, time, density, temperature, speed, and distance, while in vector, weight, acceleration, force, and velocity and displacement. Vectors and scalars. Scalar is a physical quantity which is specified by 1. A number which represents the magnitude of the quantity. 2. The measuring unit. Scalar physical quantity can be added, subtracted, multiplied, or divided. Its example includes mass, distance, speed, density, volume, time, temperature, energy, charge, work, and potential. Vector physical quantity which is specified by 1. A number which represents the magnitude of the quantity. 2. The measuring unit as 3 meters. 3. A specific direction. This means a vector is a representation of both quantity and direction at the same time. Its example includes displacement, force, velocity, and acceleration, gravity acceleration. There are some physical quantities that seem at first sight to be similar, but they have a great difference in their concept, such as distance and displacement, speed and velocity. This car moves from point A to point B, may in curved line or zigzag line. This length gives the distance covered by the car, as the distance is the actual length of the path that the moving object takes from the start point to end point. So distance is a scalar and has magnitude only. While if the car moves in a straight line from A to B, this length gives the displacement, as displacement is the length of the shortest straight line between two positions, primary and final. So it is a vector and has magnitude and direction, start from A to B. So displacement means it is the distance covered at a certain direction. If your friend tells you his car 50 kilometers away from his home, can you find it easily? It is difficult. It may be here or here or here. Which direction will you go? 50 kilometers gives the distance, which is a scalar physical quantity as it has magnitude only. While if you know the direction toward, for example, toward the northeast, it is a vector quantity which called displacement as it has magnitude and direction. Comparison between speed and velocity, or average speed and average velocity, to understand the difference between them. Firstly, from the previous, you know that speed is equal distance over time, while velocity now equal displacement over time. From the rule, we find that speed means it is the distance traveled per unit time or the rate of change of distance, while velocity means it is the change of displacement per unit time in a given direction. In speed, no direction, so it is a scalar physical quantity has magnitude only, while velocity is vector physical quantity has magnitude and direction. And both of them have the same unit, which is meter per second or kilometer per hour. Velocity, it is the speed in a given direction, as it is a vector has direction. Speed is considered scalar physical quantity as it has magnitude and no direction. In case of velocity, however, the direction is stated, so velocity is vector physical quantity as it has magnitude and direction. So any physical quantity has magnitude and direction, it is described as vector physical quantity like velocity. To describe a scalar physical quantity, it is enough to know that magnitude only, numeric value and measuring unit. To describe a vector physical quantity, it is necessary to know the magnitude and direction. Each of the following happens. The amount of distance equal to the amount of displacement happens when the body moves in a straight line. When the displacement of the moving body equals 0, when the body returns back to its primary position. Did you know cheetah is the fastest animal in the planet? Nothing on the earth runs faster than cheetah does. Its speed is about 27 meters per second. Magnitude only, as the speed is scalar. But if we want to represent its velocity, we say that its velocity is 27 meters per second in a certain direction. As velocity is vector, we must determine its direction. Why this flight takes more time toward Hollywood than this flight? The movement of wind arises from the difference of air pressure in different regions above the Earth's surface, and arises from the movement of Earth around itself from west to east, affected the direction of wind, which affects the value of the velocity of the plane. So, pilots take in consideration the velocity of wind, because the direction of wind affected the velocity of the plane, and the time of the trip and the amount of fuel which is consumed. Air pressure not even in all places. Now let's see how wind speed and the air pressure are related to each other. The high air pressure in region X comparatively low pressure in region Y. So air moves from X to Y. Does that mean the difference in air pressure causes the movement in air? Yes, that's true. The difference in air pressure results in wind. But how does the speed of wind increase or decrease? The answer is simple. If the difference air pressure is high between the two regions, the air moves faster and vice versa. Movement of air reduces the air pressure, as wind is the movement of air from the high pressure region to low pressure one. To solve a problem of distance and the displacement of body move in a straight line, remember that in a square, all sides are equal. While in rectangle, every two opposite sides are equal. If the body moves from A to B to C then to D in three perpendicular directions, its distance equal AB plus BC plus CD. In a square, all sides are equal, so distance equal 3 multiply 50 or 50 plus 50 plus 50, which equal 150 centimeter. But in rectangle, every two opposite sides are equal, so distance equal 50 plus 100 plus 50, which equal 200 centimeter. While the displacement is the shortest straight line between the start point and the end point, so it is the length of AD. eastward from A to D. The displacement in square 50 centimeter, while in rectangle is 100 centimeter eastward. While if the object returns back into its start point from D to A, its displacement equals 0 at the start point is the end point. If the body moves in two perpendicular directions from A to B then to C, its distance equal AB plus BC. So equal 15 plus 20, which equal 35 centimeter. According to the Pythagorean theorem, its displacement equal the length of AC. So the displacement equal AB square plus BC square under square root, which equal 25 centimeter in the direction AC, as displacement is vector. When the body moves in a circular path, to solve the problem of distance and displacement, remember that the radius of the circle equal half its diameter. When the body moves in a complete circle, distance equals circumference, which equal 2 pi r. So equal 2 multiply 22 over 7 multiply 7, its radius equal 44 meter. If the body moves in a half circle, so its distance equal half circumference. While when move in quarter circle, simply its distance quarter circumference. If move in 3/4 circle, for sure distance equals 3/4 circumference. If the body move in a complete circle, its displacement is the shortest straight line between the start point and the end point. So, if the body move in a complete circle, its displacement equals 0, as the start point is the end point. While when move in a half circle, the displacement is the length of AB. So, it is equal the diameter, which equal to multiply r in the direction AB eastward. While in quarter circle and 3/4 circle, according to the Pythagorean, the displacement equal r square plus r square under square root.